Modernage MCQs Physics First Year Unit number 8 Waves Part 2. The speed of a wave in an elastic stretch string is 5 meters per second. What will be the speed if tension is increased to 4 times? Option A 5 meters per second. Option B 10 meters per second. Option C 15 meters per second. Option D 20 meters per second. The key is 10 meters per second. Therefore, the correct option is B. Reason. The formula for the speed of a wave in an elastic stretch string is V is equal to square root T into L divided by M. For tension T1, V1 is equal to T1 into L divided by M whole square root. And for tension T2, V2 is equal to T2 into L divided by M whole square root, which is equal to square root 4T1 into L by M, because T2 is equal to 4T1. Taking 4 outside, we have 2. Therefore, V2 is equal to 2 into square root T1 into L by M, which is equal to 2V1, because T1 into L by M square root is equal to V1, which is equal to into 5. V1 is given, which is 5 meter per second, or V2 is equal to 10 meters per second. Hence, speed increases from 5 meter per second to 10 meter per second. The speed of a pulse in a stretch string is 6 meters per second. What will be the speed if tension is increased to 4 times and mass per unit length is increased to 8 times? Option A 9 meters per second. Option B 6 meters per second. Option C 3 meter per second. Option D 1 meter per second. The key is 3 meters per second. Therefore, the correct option is C. Reason. The formula for the speed of a wave in a stretch string is V is equal to square root T into L divided by M, which is equal to square root T divided by M divided by L, where M divided by L is mass per unit length and it is denoted by small m. Therefore, the speed V is equal to square root T divided by small m. For tension T1 and mass M1, V1 is equal to square root T1 divided by M1, and for tension T2 and mass M2, V2 is equal to square root T2 divided by M2, which is equal to square root 2T1 divided by 8M1, because T2 is equal to 2T1 and M2 is equal to 8M1, or V2 is equal to T1 divided by 4M1 square root, taking 1 by 4 outside. V2 is equal to 1 by 2 square root T1 divided by M1, or V2 is equal to V1 divided by 2, which is equal to 6 divided by 2 is equal to 3 meters per second, because V1 is equal to 6 meters per second given. Hence, the speed decreases from 6 meters per second to 3 meters per second. In a medium of elasticity E and density ρ, the speed of longitudinal waves is given by option A rho into E, option B square root rho into E, option C E divided by rho, option D square root E divided by rho. The key is square root E divided by rho. Therefore, correct option is D. Reason. In a medium of elasticity E and density rho, the formula of speed of longitudinal waves is V is equal to square root E divided by rho. Hence, the speed of longitudinal wave is given by square root E divided by rho. The velocity of a wave in a medium depends on option A, homogeneity of medium, option B, density of medium, option C, elasticity of medium, option D, A, B, and C. The key is A, B, and C. Therefore, the correct option is D. Reason, formula, V is equal to square root E divided by rho. The velocity of waves depends on density and elasticity E. It also depends on the homogeneity of the medium because rho and E depend on the homogeneity of medium. Hence, the velocity of a wave in a medium depends on homogeneity, density, and elasticity of medium. Option D, A, B, and C. The wavelength lambda, frequency f, and velocity v of a traveling wave are related as option A, v is equal to f divided by lambda, option B, v is equal to lambda by f, option C, f is equal to lambda by v, option D, f is equal to v divided by lambda. The key is f is equal to v divided by lambda. Therefore, the correct option is D. Reason, the velocity v of a traveling wave is proportional to wavelength lambda. That is, v is proportional to lambda. Therefore, v is equal to constant into lambda, which is equal to f into lambda, where f is the constant of proportionality and it is estimated as the frequency, or f is equal to v divided by lambda, because the constant of proportionality in this case is the frequency of waves. Hence, the relation is f is equal to v divided by lambda. A wave propagates through a medium with velocity 50 centimeter per second. The time period of oscillation of particles of medium is 2 seconds. The wavelength of the wave is equal to option A 200 centimeter, option B 100 centimeter, option C 50 centimeter, option D 25 centimeter. The key is 100 centimeter. Therefore, the correct option is B. Reason, formula. The speed of wave is equal to frequency of the wave into wavelength, which is equal to lambda divided by t, because frequency is inverse of the time period t, or lambda is equal to v into t. The time period of oscillation of particles of the medium is same as the time period of wave. Therefore, lambda is equal to v into t is equal to 0.5 meter per second into 2 seconds, which is equal to 1 meter, is equal to 100 centimeter. Hence, the wavelength of the wave is equal to 100 centimeter. A wave propagates through a medium with velocity 50 centimeter per second. The time period of oscillation of particles of the medium is 2 seconds. What is the frequency of the wave? Option A 5 Hz, option B 3 Hz, option C 1.5 Hz, option D 0.5 Hz. The key is 0.5 Hz. Therefore, correct option is D. Reason, formula of the frequency is equal to 1 divided by T. The time period of oscillation of particles of medium is same as the time period of wave. Therefore, f is equal to 1 divided by 2, because the time period is equal to 2 seconds, which is equal to 0.5 hours. Hence, the frequency of wave is 0.5 Hz. Newton calculated the speed of sound to 81 meters per second in air by applying option A, adiabatic process, option B, isochoric process, option C, isothermal process, option D, isobaric process. The key is isothermal process, therefore the correct option is C. Reason: the formula derived by Newton is V is equal to square root pressure divided by rho is on the basis of isothermal process where pressure is equal to rho mgh, where rho m is the density of the mercury, g is the gravitational acceleration, h is the height of the mercury column divided by rho whole square. At standard temperature pressure, substituting the density of mercury, rho m is equal to 13.6 gram per cubic centimeter, and the density of air, rho is equal to 0.001293 gram per cubic centimeter, g is equal to 980 centimeter per second, and height h is equal to 76 centimeter. We get v is equal to 28 100 centimeter per second, which is 281 meter per second. Hence, the speed of sound to 81 meters per second is by applying isothermal process. Laplace corrected Newton's formula by applying option A, diabatic process, option B, isochoric process, option C, isothermal process, option D, isobaric process. The key is adiabatic process. Therefore, the correct option is A. Reason: the Newton's formula is V is equal to square root rho m g h divided by rho, which is equal to 281 meter per second, which is the speed calculated by the Newton. It is modified by Laplace to the formula V is equal to gamma rho m gh divided by rho square root, taking the gamma outside, uh, gamma square root into square root rho mgh divided by rho on the basis of adiabatic process. The constant gamma is the ratio of the specific heat at constant pressure to specific heat at constant volume, which is equal to 1.42 for air. Therefore, the speed of sound in air calculated by Laplace is V is equal to gamma square root into 281 or V is equal to square root 1.42 into 281. Simplification gives 333 meters per second, which is close to the experimental value. Hence, Laplace corrected the formula by applying adiabatic process. The velocity of sound in vacuum is option A 333 meters per second, option B 332 meters per second, option C 281 meters per second, option D 0 meter per second. The key is 0 meter per second. Therefore, the correct option is D. Reason: the sound waves are mechanical waves. They cannot travel through vacuum. Hence, the velocity of sound in vacuum is 0 meter per second.